My name's Holden Nelson. I'm a chemistry major at Westfield State University, and over the summer of 2020, I was awarded a summer research fellowship through the Center for Undergraduate Research and Creative Activities, CURCA's SURF program, where together with my research mentor, chemistry professor Professor Acevedo, I was able to do an independent research study about the chemical pollution of the Housatonic River. My interest in this project was simple. I grew up in Dalton, Massachusetts, right off the east branch of the Housatonic River. A few miles downstream from Dalton lies the old factory grounds of the Pittsfield General Electric plant. Growing up in the area, I had always heard that you should never eat the fish from the river because it was chemically polluted with polychlorinated biphenyls, PCBs for short. After several years of negotiations between the EPA and other parties, the draft plans for the final phase of the Housatonic's remediation were released. Their proposed solution was to dredge the rest of the river. This raised a local outcry, as it required a landfill to be built near one of the towns further downstream. The citizens, having dealt with this pollution for decades, perceived the settlement as either ineffective or downright hazardous. I, too, was not happy with this outcome and was inspired to investigate the established and emerging chemical mitigation methods available to determine if there were better ways to clean up the Housatonic. As part of my literature review, I looked into the effects and efficacy of dredging. Though a popular way to remove PCB contamination from a river, it is also one of the most destructive. Soil is physically scooped from the bottom of the river and dried before either being buried or treated. This process by itself does nothing to reduce the amount of or neutralize the PCBs, leaving them with the potential to cause damage elsewhere if not handled properly. In truth, much of this project has been about learning how to convey information as much as it's been about finding it, and Professor Acevedo has been especially helpful with this. He's helped me in deciphering the denser scientific papers I found that were based on concepts I haven't learned in class yet, and he's also taught me much about the conventions of writing scientific publications. In my literature research, I had found some preliminary studies using less destructive remediation methods, but did not know if they had been considered as potential strategies on the Housatonic. Professor Acevedo suggested that we talk to an expert in the field, and so I arranged an interview with an EPA official close to the project. The EPA official was able to confirm that such studies had been considered. One such failed case is from the early 1990s, in which biologists attempted to extract PCB-eating bacteria from Woods Pond. While these alternate approaches can work in other environments, they're impractical for use in the Housatonic. Each mitigation plan needs to be tailored to the reality of the environment in which they'd be applied. Ultimately, despite my initial gut reaction, I discovered that the proposed landfill was actually not that harmful. There are several safeguards, testing operations, and leak detection methods being implemented to prevent the landfill from leaching material into the ground. In the small possibility it does leach, steps are already in place to clean up and remove the PCB waste. Post-closure, the PCBs will be sequestered in the natural carbon from the river sediment, meaning the land above the landfill can be safely converted for public use, perhaps as a public park or a solar farm. While no one wants a landfill in their backyard, the alternative, leaving it in the river, is much worse for both the environment and the community. Overall, my work with Professor Acevedo gave me critical insight into how research theory is applied to real-world problems and how to communicate to a more lay audience. It also allowed me to draft and submit comments to the EPA on my findings. My biggest takeaways from my SURF program experience are that risk assessment and risk communication are two crucial, yet two very different skill sets necessary for working in environmental remediation. I found that publicly available information doesn't necessarily mean that information is presented in a way that is accessible to the general public. And often the most pertinent results are the hardest to find without an expert-level understanding of the topic. Moving forward, I plan to further expand my understanding of river remediation by gaining experience in the qualitative and quantitative analysis of river water. The more I know about the process of remediation, the more I can convey to my community.